Hello everyone, welcome to today's lesson on adding and subtracting sets. In my previous videos on sets, we've looked at the rule for multiplication and division, and we've seen that with the multiplication, if you have root A times root B, this is the same as root AB. And with the division, if you have root A divided by root B, this is the same as root A over B. But when it comes to the addition, if you have root A plus root B, we cannot write this as root A plus B. And we'll look at some examples soon. Let's take, for example, you have 2 oranges plus 3 mangoes. Now I'm using R for orange, M for mangoes. So I will write this as 2 oranges plus 3 mangoes. If I want to put these two fruits together, I cannot say I have 5 oranges, mangoes. This is not done because the fruits are not the same. So I will have my answer to be, I have 2 oranges plus 3 mangoes. I can only add the fruits together when the fruits are the same. So if I have 2 oranges plus 3 oranges, then I have 5 oranges. Now the 2R, which is 2 times R, is the same as 2 lots of R. And 3M is the same as 3 lots of M. Let's see how we can apply this in adding and subtracting sets. One thing we have to note is that anytime you want to add or subtract sets, make sure that the sets in the terms are simplified. Now, in our first example, root 3 cannot be simplified. So this one is in its simplest form. If we take the first term, which is 7 root 3, 7 root 3 is the same as 7 lots of root 3 because it is 7 times root 3. And the second term, 4 root 3, is 4 lots of root 3. And these two terms are adding. So how many root 3s do we have? This will give us 11 lots of root 3. So when you are adding sets and you have like terms, now in this case we have root 3 in the first term, root 3 in the second term. So these are like terms. So all we have to do is to add their coefficient. Now we have 7 as our coefficient in the first term and plus 4 coefficient in the second term. So we add these two numbers together and we get 11 root 3. So our first example is done. Let's look at the next example. In the next example, all the sets are simplified. So let's group the like terms. If we pick the first and second term, these are not like terms because in the first term, when you check the number in the square root, it is 2. In the second term, the number in the square root is 3. So they are not like terms. But the first term and the fourth term are like terms because we have root 2, root 2. So we will write this as 3 root 2 plus 6 root 2, which is 3 lots of root 2 plus 6 lots of root 2. And this will give us 9 lots of root 2. We have other like terms. We have 4 root 3 and 5 root 3. And we write this as 4 root 3 minus 5 root 3. This case, 5, we are subtracting 5 from 4. So we have 4 minus 5, and this will give us minus 1 root 3. Now we have minus 1 as coefficient, and when you have 1 as coefficient, we make the 1 invisible. So this is the same as minus root 3. We are left with negative 5 in the expression. Now let's put our answers together. So we will have 9 root 2 minus root 3 minus 5. And this will be our final answer to the second question. In these examples, we need to simplify the sets before we can add. So when we pick the first example, we have root 40 plus root 10. We have to simplify root 40, but root 10 cannot be simplified because we cannot find a square number that is a factor of 10 except 1. So let's pick root 40. Root 40, what square number is a factor of 40? That square number is 4. So we write this as 4 times 10. And this is equal to root 4 times root 10 when we apply the rule for multiplication. Root 4 is equal to 2. So we get 2 root 10. So instead of root 40, we will write 2 root 10. Let's put everything together. So we write 2 root 10 plus root 10. And this is 2 lots of root 10 plus root 10. And this will give us 3 lots of root 10. And that is done. Now, in the square root, we have 10, So these are like terms, so we can put them together. Let's do the second one. We have root 125 minus root 75. We have to simplify all the sets before we put them together. So let's take root 125. What square number is a factor of 125? The square number is 25. So we write this as 25 times 5. And this is the same as root 25 times root 5. So we get 5 root 5. And we pick 75, which is the square number is 25. So this will give us 25 times 3. And this is equal to 5 root 3. Now we have simplified our set. So let's put everything together. So we write this instead of root 125. We are going to put this one there, and 75, we'll put this one there. So we have 5 root 5 minus 5 root 3. Are these like terms? No, because in the square root, when you check the first term, we have 5. The second term, we have 3. These are not like terms, so we cannot add or subtract the coefficient. So our final answer is going to be this one. Let's look at our last example. Now, before we can solve this, we have to simplify the set. So we pick the first one, which is 300. And what square number is a factor of 300? You can think of 25, but I'm going to use 30. If you start with 25, then you have to simplify it till your final answer is in its simplest form. But in this case, I'm going to use the highest square number, which is a factor of 300. So the highest square number is 100. So we have 100 times 3. And this is the same as root 100 times root 3. And we get 10 root 3. We pick 27. The square number is 9, so we have 9 times 3, and this is root 9 times root 3, which is equal to 3 root 3. We can simplify root 3, so we pick 108, and this is 36 times 3. 36 is a square number and it's a factor of 108. So we get root 36 times root 3. And root 36 is equal to 6. So we get 6 root 3. So let's put everything together. Now, instead of root 300, we are going to write 10 root 3, and instead of 27, we have 3 root 3 minus our root 3 all over 6 root 3. Let's simplify the numerator. If we check the terms in the numerator, the terms are the same because we have root 3, root 3, root 3. So let's add the coefficient. So we are going to have 10 plus 3, which is 13, and then minus 1. The coefficient of this root 3 here is -1. So 13 minus 1 will give us 12 root 3 all over 6 root 3. Now we have root 3 in the numerator, root 3 in the denominator. So we can cancel that and we'll be left with 12 root 3, which is equal to 2. You can check this in your calculator. This brings us to the end of today's lesson. Please subscribe to my channel and kindly share with your friends and families to also subscribe. See you soon in my next video.